Radar sees everything. Ships, missiles, fighter jets moving at twice the speed of sound. Everything. Except this. The F-117. Nighthawk wasn't just a stealth aircraft. It was a flying contradiction of physics. In January 1991, American pilots took off from Saudi Arabia. Their target, downtown Baghdad, one of the most heavily defended airspaces on the planet. Thousands of radar systems, surface-to-air missiles, anti-aircraft guns on every rooftop. The Iraqi operators stared at their screens all night. They saw nothing, because as far as radar was concerned, nothing was there. This is the story of how engineers made a 23-ton aircraft invisible. To understand stealth, you first need to understand what you're hiding from. Radar works on a simple principle. Send out a radio wave, wait for it to bounce back. Calculate the distance, speed, and size of whatever reflected it. That is reflection. Engineers call it a radar cross-section. The bigger the object, the stronger the return signal. A commercial airliner has a radar cross-section, roughly the size of a large building. An F-117 fighter jet, about the size of a car. The F-117, the size of a marble. A single, small marble on a radar screen in the middle of the night, moving at 600 miles per hour. By the time an operator might question what they're seeing, it's already gone. But achieving that marble-sized signature didn't happen by accident. It required rethinking everything about how an aircraft is designed, from the ground up. Most aircraft are designed around one principle: aerodynamics. Smooth curves, rounded edges, shapes that let air flow cleanly around the fuselage. The F-117 threw that rulebook away. Look at it from any angle. It's wrong. Sharp facets, flat panels, angular surfaces that look more like a broken diamond than an aircraft. Early test pilots called it the Wobblin' Goblin because it was so aerodynamically unstable, no human could fly it manually. But those ugly angles had a purpose. When a radar wave hits a curved surface, it scatters, but some of it always bounces straight back to the source. That's the return signal. That's what gets you detected. When a radar wave hits a flat-angled panel, it deflects, not back to the source, away, off into empty sky where no receiver is waiting. The F-117's entire outer skin is calculated. Every panel, every edge, every angle, precisely positioned to redirect radar energy away from its origin point. Lockheed's Skunk Works engineers ran thousands of calculations. In the 1970s, doing this by hand was nearly impossible. So they built one of the earliest computer programs, specifically to model radar reflection off geometric surfaces. The result was a shape that had never existed before. Ugly, unstable, and almost completely invisible. Shape alone wasn't enough. Even perfectly angled panels have edges, joints, gaps where panels meet, and those imperfections, those tiny physical seams, scatter radar energy in unpredictable directions. So Lockheed engineers added a second layer of defense: radar-absorbing material, RAM coating. This isn't paint, it's a composite material. Layers of iron ball particles suspended in a polymer matrix, applied across the entire aircraft surface. When radar waves hit this coating, instead of reflecting, they're absorbed, converted into tiny amounts of heat energy, dissipated, gone. Think of it like this. A mirror reflects light. A black wall absorbs it. RAM coating turns the F-117 skin into a black wall for radio waves. But there's a cost. RAM coating is fragile. It degrades with heat, moisture, and physical stress. After every mission, ground crews spent hours, sometimes entire nights, inspecting every inch of the aircraft, reapplying coating, sealing seams by hand. The F-117 required more maintenance per flight hour than almost any aircraft in history. Invisibility is expensive. Radar isn't the only way to find an aircraft. Modern air defense systems also track heat signatures. Jet engines burn fuel at extreme temperatures. The exhaust plume from a conventional fighter jet is visible on infrared sensors from miles away. The F-117 solved this with one of its strangest design features. The engine exhausts are not round nozzles like every other jet aircraft. They're wide, flat slits, horizontal slots positioned on top of the fuselage, angled upward and away from ground-based sensors. The hot exhaust mixes with cool outside air before it exits. The heat disperses faster. The infrared signature dramatically reduced. Additionally, the engine air intakes are covered with metal grids, fine mesh screens that prevent radar waves from entering the engine cavity, because the inside of a jet engine is a perfect radar reflector. Without those screens, the intake alone would light up enemy radar like a lighthouse. Every opening, every gap, every surface, engineered to disappear. The F-117 was retired in 2008, officially. But stealth technology didn't retire with it. Everything learned from the Nighthawk, the geometry, the materials, the thermal management, went directly into the B-2 Spirit, the F-22 Raptor, and today's F-35. Modern stealth is smoother, more aerodynamic. Computers powerful enough to calculate stable flight paths for unstable shapes, solving the problem that made the F-117 wobble. But the core principle remains unchanged. Don't be faster than the missile. Don't fly higher than the radar. Just disappear. The F-117 proved it was possible. A 23-ton aircraft, invisible to every system designed to find it. Not through speed, not through altitude, through engineering.